Good morning, everyone. It's an absolute pleasure to welcome you all for the special edition of our Manufacturing 4.0 webinar series. We have been here before, and the response was overwhelming. And thank you for your enthusiasm and thought provoking interactions. We knew we had to come back, but this time with more industrial cases, deeper insights, and richer learning experience straight from the field. So, whether you are joining as a again or tuning into the first time, we welcome you. And this session is going to be a more insightful for the day. Let me quickly introduce myself. I am Pravinash Shenoy, and I have a privilege of serving as country manager for India at Opsio. Over the years, I have been worked closely with the organization undergoing a digital transformations journey, especially in the manufacturing sector. It's an exciting space, and today I will be thrilled to be your host. But expert opinions are very crucial, right? Therefore, join me today is a fantastic mind in the field, Sri Vaishnavi, our director and an expert in AIML application for industrial system. Vaishnavi bring a rare blend of strategic thinking and hands-on technical insight, having led several implementation of advanced manufacturing analytics, predictive maintenance, and intelligent automation across the sector. Welcome to the webinar, Vaishnavi.
Thank you, Prana.
So now let's dive into more on manufacturing 4.2 and let's learn more about it. The landscape of manufacturing is undergoing a seismic shift from AI-driven process optimization to real-time monitoring using IoT, and from digital twin autonomous production lines for the fourth industrial revolution is no longer the buzzword. It's a tangible reality. But transformation does not happen in vacuum, right? So it required the right technologies, the right strategies, and the most importantly, the right insight. So that today's session will explore a real world case studies that demonstrated the impact and how the AIML is practically solving the problems on your shop floor. And the roadmap, which we are going to say, it's scalable, sustainable digital innovation into a manufacturing setup like yours. So therefore, let's aim to learn, exchange, and build a future of manufacturing together. Before that, let me take you through the agenda quickly. Well, we begin today's session by introducing you about Opsio, who we are, what we do, and how we can help the business across the industries innovate smarter and faster way. From here, we move into a heart of the discussion, which is a smart production roadmap. We will walk you through how the businesses are moving beyond the traditional linear manufacturing process and embracing the intelligent, connected workflows. This includes everything from the real-time monitoring and data-driven decision making to adaptivity, autonomous, and operations. Next, we will explore the key technologies trends that are reshaping the industry today, from digital twin to predictive maintenance. That's how minimize the downtime and maximize the efficiency with examples. And finally, we will show you how Opsio help you to build the solution inside your manufacturing with the proof of concept. So let's begin to share about Opsio first. We are a sustainable innovation partner. Our focus is to facilitate a significant innovation and cutting-edge technologies into your ecosystems and relieve you from your operational burden so that you can focus on your business goals. B, take your IT operation on our shoulders and drive you towards the successful implementations and manage them with top-notch quality of services. Currently, we operated in two regions. Our headquarters is in Sweden, Karlstad, and our regional office is in Bangalore, India. Both locations are equally equipped with a similar headcounts and the technologies serving the need of our respective regions. Under the Make in India initiative, we undertake the global project and deliver a top-notch solution from our Bangalore office. As many of you know, certifications are a very vital benchmark for expertise. And at Opsio, we take great pride of having 100 plus industrial recognition certifications across our team. To strengthen our capacities and capabilities further, we have an advanced partnership with the leading cloud providers such as AWS, Microsoft Azure, and Google Cloud platforms. In addition to that, cloud expertise, we also bring a deeper proficiency in on-premises environment, including VMware, which remain essential for many of our clients from hybrid IT network. We are very proud of having successfully completed or delivered a 3,000 plus project across the globe, and we continue to maintain our impressive 99.5% customer satisfaction rate till today. Our customer portfolio span multiple sectors, reflecting our abilities to deliver a sector-agnostic, scalable solutions that adapt to unique industrial challenges. And below, you will see a few of our key customers from diverse industries. Now, let's shift our focus and explore how the manufacturing landscape is evolving in today's digital era. So, AI adaptation is revolutionizing in Indian manufacturing landscape without no further doubts. In just past 2 years, adaptation has surged by 20%, and according to the recent study, 54% of the companies have already integrated AI services into their operations. But this is just the beginning. By 2025, 40% of the manufacturing expenditure is expected to be direct towards the digital technologies, which double allocation what we have seen in 2021. That's a clear signal of where industry is exactly heading. And with that AI market in manufacturing projected to grow nearly by 59% annually. This isn't just passing trend, it's a future of industrial innovation. So most of the competitors, including yours, are already leveraging AI to scale faster, operate smarter, and innovate deeper. But now it's time to act and time to lead. Together, we can dive into a Industry 4.0 transformation to unlock the powerful opportunities for growth, efficiency, and success. So let me walk you through how our leading companies kickstarted their AI journey with Opsio and how you can take a first step towards it. With the support of Swedish Embassy and Business Sweden, we had an incredible opportunities to engage in meaningful conversation with several companies that are making impressive strides in the adaptation of AI ML technologies. While I won't mention this organization by name, many of you will recognize them instantly by looking at their logo. They are just industrial giants, each playing a pivotal role in Indian economical growth and innovation ecosystems. What is particularly excited here is the diversity of the sectors. These companies represent on the side you get easily notified the leaders from the steel, paper, hospitality, even in the neighboring government sectors, each exploring how AI ML can optimize the operation and boost the efficiencies towards deliver a smart outcomes. And with that, let's quickly move to the next slide. As you can see here, we are joined by the companies from the wide range of sectors like retail, e-commerce, manufacturing, energy, so on and so forth. So their progress in AI and ML adaptation is truly setting a benchmark. These are the real world examples of how a digital transformation is not just a buzzword, it's a strategic necessity driving efficiencies, agilities, and innovation across the industry. So let's be very honest, it's inevitable. Therefore, ladies and gentlemen, get ready. We are about to embark on in-depth explorations of innovations, tool, and technology shaping the future of manufacturing 4.0. Today, you'll discover the real-world cases, hear inspiring success stories, and gain valuable insight into investment and actionable strategies. By the end of this session, you will have a clear understanding of how organizations are transforming digital strategies into measurable result. And now, to guide us through this exciting journey, I'm delighted to introduce my colleague Vaishnavi. Vaishnavi, the stage is yours.
Thank you, Pravina, for that kind introduction. It's always a pleasure to be with everyone and again today. As Pravina mentioned, today's topic is very familiar to everyone but important to be kept as priority as it holds a very valuable source for everyone. So let's start understanding more with an imagination first. Let's imagine standing on the floor of a factory where the machines are operating as usual, teams are working busy, and the day is progressing as expected. But as the minute passes, small challenges begin to surface, quality checks slips through, and machines start to show the signs of wear and tear, and decision making becomes more reactive and challenging. Now let us also picture this, a factory where and which doesn't respond to problems as they come, it anticipates them. So it knows when a machine is likely to fail, detects inconsistency in real time in terms of quality, and adapts without waiting for those manual interventions. So in this scenario, not only are disruptions are minimized, but the entire operation is optimized, delivering the consistent performance day after day. So this is the exact promise of manufacturing 4.0. It is not just a concept that has been around for years in principle or an aspiration that the businesses wants to be. It is a powerful evolution that is taking place right now, driven by many advanced technologies from its previous versions and that are shaping the very fabric of manufacturing. So, today we will guide you through a refined overview of this journey, highlighting some of the most impactful and accessible applications that are already helping many of the manufacturing facilities. So, let's take a top down approach to start with and see what is a McKinsey report tells us about manufacturing 4.0. On the slide, as you can see, there are some prominent figures in blue, that is 5.5 billion to 12.6 trillion USD. So these numbers represent the potential global savings that businesses would gain by 2030 through the adoption of smart manufacturing technologies. The scale is immense, almost unbelievable, and rightly so. But instead of feeling overwhelmed by these numbers, we should view them as a powerful testament to the tangible results that we can get by embracing smarter, sort of a more connected manufacturing systems. Now, naturally, we all get this question that where do these savings actually come from? And the answer is very clear. These are savings that the companies are projected to see comes from overcoming some of the fundamental operation challenges that we have been seeing for decades. And that is how effectively we can reduce the waste, boost productivity as we scale, and also optimize a resource, especially when the production volumes touches the roof. And all of these improvements are driven by the core pillars that form the foundation of manufacturing 4.0. Now let's see what are these pillars in detail. Digitization. So this is indeed the foundation of digital transformation. In the current day and age, data is considered the new oil. So turning these raw data into valuable information through technologies like IoT, AI, and ML allows us to make informed decisions and gain that competitive advantages in the market. So without digitization, a company probably would struggle to scale or even to function efficiently in today's tech-driven environment. Next is automation. Once the digitization is in place, automation becomes a next logical step. The goal here is to reduce repetitive manual tasks, eliminate those daily human errors, and make processes faster and more reliable. So it's not just about speeding the things up in the production. Automation ensures consistency, improves the quality over time, and also enhances the productivity, helping us to handle the task at scale with minimal intervention. And as mentioned with the manufacturing plant example, real time machine learning and AI algorithms can help us to have those systems to adapt automatically to the changes that we see in a day to day basis. Next is integration. Integration is indeed a critical aspect because automation and digitization only work when all the different pieces of businesses ecosystems, that is systems, departments, machine, and of course people, can communicate with each other. So this ensures that data is flowing throughout the plant freely and decisions are made based on a complete and a unified view. And the idea of integration is to break down those silos silos or the departments, which are often the barriers to those agility, innovation, and effective decision making gains that we can get. So, a fully integrated system enables smoother workflows and a more real time, accurate decision making as departments and processes are aligned. Next is flexibility, which is an absolute essential in today's rapidly changing business world. So markets evolve, with that customers' demands also evolve and they shift, and new technologies emerge constantly. Companies have to be able to pivot and adapt quickly in these changing environments. And having a flexible systems and solution that ensures that the business is not tied down to an outdated processes or rigid infrastructures that cannot scale. So being adaptable gives businesses the agility to seize new opportunities that they can see and respond quickly to the challenges, ensuring long-term competitiveness. So, yes, these are the pillars that are widely recognized as the backbone of digital transformation. When implemented correctly, they can lead to more efficient, scalable, and responsive business operation that drives the growth and sustainability in today's dynamic environment. Now, let's see some of the key benefits of manufacturing 4.2 that drives the impact. First is efficiency. So having efficiency is not just about the speed, like I mentioned, it's about maximizing the output while minimizing the waste. So predictive maintenance and real-time optimization ensures that resources are used effectively, cutting downtime and increasingly reliability. Data-driven quality. By using real-time data, we can remove the guesswork that we do during the operations, where machines can detect issues before they happen, improving product quality and reducing defects without delays. Cost savings. Manufacturing 4.0 helps us to adjust cost dynamically by optimizing resources, cutting waste, and responding swiftly to the market shifts, and we can stay cost efficient and adapt in uncertain times as well. Sustainability through efficiency with lower energy consumption and reduced material waste, it helps us to meet sustainability goals while improving their environmental footprint. So it's a win-win situation for the both bottom line and our ecosystem. Next is innovation. It also fosters an environment of continuous improvement, helping us to stay competitive and quickly innovate in response to new technology emerging. So, how do we translate all of this into our real world value for us? So, the true value of what we looked previously comes from becoming data driven. So, at the heart of what we are discussing today is data driven decision making. So, it's about shifting from sort of a guesswork mindset to making decisions based on real data generated by the production teams. So through the right technologies, we can predict and prevent problems before they even rise, adapt quickly, whether it's adjusting the product, the process, or the entire operation at scale. Integrate technologies like IoT and AI/ML to build a cohesive, sort of a seamless networks that communicate effortlessly. And with increase in agility and scalability, we can grow, pivot, scale, or even shrink as needed, but always with that data driven information at hand guiding us the way. So, this is not just about using the technology for the sake of it, for the sake of utilizing it. It's about using these technologies as the building blocks of smart manufacturing, which is the core of manufacturing 4.2. But we must be very clear with one thing, that these technologies are not magic. They are tools which are very powerful that extend what we already do and help us to do it better. And then we might wonder, what is the real challenge here? So the real challenge is that knowing when and how to use these tools effectively. So that is what manufacturing 4.0 is all about. The purpose driven, intentional applications of AI, ML, and IoT to achieve the outcomes that matter most for us, and that is efficiency, adaptability, and scalability of our businesses. Now, to truly understand the gravity of this and where we are headed, it's essential to pause and reflect on how far we have come. So, when we see the history of industrial progress, the evolution is not only impressive but also very informative. So, in 20th century, it marked the beginning of industrial revolution as we know it. This was a time of foundational change, the rise of machinery, mass production, and the early stages of standardization. But it was still a world which was largely driven by human expertise and manual oversight because optimization often relied on key judgment of the operators, constant monitoring and observation, and reactive interventions to manage those operations. Today, in 2025, we find ourselves in the early stages of intelligent manufacturing. Factories today are not necessarily replacing existing systems, but rather enhancing them. Smart technology in the form of sensors, IoT devices, and connected platforms now helps us to gain that real time visibility and control over those systems. Data, which was once a byproduct of the production, is now a strategic asset for the businesses, and we call it as a new oil in this era. The shift from manual oversight to data driven decision making is not a distant goal anymore. It's happening right now as we speak. Now, when we move to 2030, as we look ahead, the next phase we will see a further shift towards predictive and proactive systems. We can expect predictive maintenance becoming a standard practice, adaptive production lines that adjust in real time, and also operational decisions which are informed by live data and analytics rather than the intuition or the historical data. So, this move represents a shift from reactive mindset to an anticipating mindset, from managing disruptions to preventing them to an extent altogether. By 2035, we will enter the realm of autonomous manufacturing systems, and at this stage, we will see self learning systems that continuously improve their performance, self healing machines which are capable of detecting and resolving the issues immediately, and also fully autonomous production chains managed end to end by the intelligence softwares and the cutting edge materials and the methods that will be using them, which revolutionizes the product development. Though this may sound very futuristic, but it is within our grasp and range. The advancements we make today form the foundation of what is to come tomorrow. The message with this is very clear that we don't need to leap directly into 2035, but in 2025, we have a unique opportunity to start building those smart connected systems now, capturing the immediate value we get from it while also preparing for the future. So, with that perspective, we have with manufacturing 4.0. Now, to build on our discussions on manufacturing 4.2, let's explore one of the most impactful and accessible applications under manufacturing 4.0, and that is visual inspection, which is powered by computer vision technology. When we really think about it in production lines, when it comes to quality assurance, traditionally, visual inspection has been a key element of quality assurance for us. But as production scales and complexity grows, relying on those manual checks alone is no longer enough for us. That is where AI and computer vision comes into picture, transforming the inspection process with the precision and the reliability we need in those modern manufacturing demands. So the solution is built around three core elements. One is industrial grade cameras that capture high quality images, machine learning algorithms that analyze these images to detect any deviations in the quality, and also a dashboard that delivers the quality checks whether pass or fail or highlight any defects that is there in the product, as you can see here in the dashboard. So the production teams can monitor key inspection points like bolt placement in engine assemblies, cap fitment verification, and also surface defects like scratches, dents, etc. that we want to inspect. So these insights are displayed in real time, helping us to make immediate action without disrupting the production line. To give an example on this, we recently collaborated with a manufacturer on a truck engine assembly line where one of their primary concerns was gearbox alignment. The manual inspection that they were doing often overlooked the small deviation that they used to experience, leading to rework and production delays. So, by implementing visual inspection system, the team now can gain the ability to detect those deviations instantly, allowing for a timely corrections and improved assembly precision. Over time, this will reduce both downtime and rework, resulting in a measurable productivity gains. So this is just one example of how such technologies are not only complementing our capabilities but also elevate them in the production lines, which also delivers both value, which is both immediate and long term. Now let's see what is the market value of computer vision. The market for computer vision is rapidly growing, expanding, reflecting its increasing role in manufacturing. It's no longer just a trend anymore, it's shaping the future of automated quality inspection. In 2024, the market size was at 25 billion, and in 2032, it is projected to be at 175 billion. So, this explosive growth shows how industries like automotive, electronics, and precision manufacturing are adopting this technology at an accelerated pace. Because by automating defect detection happens automatically, production teams have greater control over the quality and efficiency of their production lines, helping them to achieve more with the existing resources. Now let's see what is the value that visual inspection powered by computer vision can give us. Firstly, enhanced product quality. The systems automatically detect defects with high accuracy, resulting in more consistent quality and significantly reduced waste along the line. Because it operates 24 bar 7 in real time, the system continuously observes critical points in the process, often revealing deviations or issues that might otherwise go unnoticed. By catching issues early on and reducing unnecessary stoppages of the production line, the overall production process becomes smoother, leading to improved efficiency and higher throughput for the production targets. Automation significantly lowers the dependence on manual interventions, which not only saves time for us but also allows skilled professionals to focus on high value tasks. Identifying defects at the source prevents faulty products from advancing further down the line in the production or even reaching customers, hence minimizing rework, recalls, and associated costs. The system automatically generates defect reports and logs inspection data, and this traceability supports root cause analysis and also helps production teams to make informed and data driven decision processes improvements that they want to see. So these benefits show us how visual inspection is not just a tool for quality control, it's one of the strategic asset that strengthens the entire manufacturing value chain. Now that we have understood the value of visual inspection, let's see how the process works in practice. Firstly, image acquisition. Like I mentioned before, the process begins with high resolution industrial grade cameras that continuously captures visual data, either as a static images or video frames on the production lines. Then these visual samples are then sent to the vision systems where they are processed and prepared for the detailed analysis. Then advanced AI algorithms analyze this data, identifying if there are any subtle patterns or the variations or any deviations in the quality that might indicate potential defects or quality issues in the production. As the analysis happens, real-time insights are displayed on the dashboard that we saw earlier, providing production teams with instant feedback on product quality. When a defect is when a defect or any small deviation is detected, the system automatically triggers predefined actions. It could be alerts to operators or email to make such adjustments to the process, ensuring a quick and effective response then and there. Then the system monitors the product quality in a continuous loop, helping to maintain the compliance with the quality standards and improving the reliability over time. So together, these steps form a closed loop quality control mechanism, one that is not only enhances the inspection accuracy, but also helps us to get smarter or sort of a faster decisions on the shop floor. Now, having explored how visual inspection operates, let's now summarize the core benefits and the associated cost of adopting this solution. Firstly, as we know this, the system achieves 99% accuracy in detecting defects, far surpassing the limits of manual inspection. So this precision minimizes the errors that we see on a day-to-day basis, reducing the likelihood of defective products reaching the market and ensures higher quality standard products distributed in the market. Since defect detection is both automatic and instantaneous, this makes the speed more critical and the ability to scale operation without compromising on quality, and which becomes a key advantage of using such application. By integrating visual inspection into the production workflow, both speed and quality are enhanced, and this results in consistent reliability output across a large volume of products, improving overall production efficiency. When it comes to cost, when we actually consider the investment in a visual inspection system, it is important that we assess both the value it delivers and its associated costs. So the starting cost for a standard system is approximately 1,30,000 per month, depending on factors like complexity of the setup and also number of cameras required. So these systems are typically deployed on on-premises, meaning there are no recurring cloud costs unless specifically requested for a cloud integration. So the final cost might vary based on additional features or the requirements of the plant. Like if the application has to be integrated with laser cameras or robotic arms or any other specialized equipments where that requires specialized inspections. So what is included in the base cost is that full implementation and deployment, ongoing operations and monitoring, SLA based issue resolution, which works on a 24 bar 7, custom dashboards for real time insights, and also training and onboarding to ensure a smoother adoption by the teams. So, given the level of automation, accuracy, and efficiency this solution offers, the return on investments, which is very compelling. So, this makes visual inspection a foundational technology in any smart manufacturing environment, which also enhances the long term operational effectiveness. Now, let's talk about another application in manufacturing 4.0, and that is predictive maintenance. So, in many manufacturing facilities, keeping machines running smoothly is very critical to hit that daily production targets. But traditionally, maintenance has followed one of these two approaches. One is being time based maintenance, where machines are serviced at regular intervals whether they need it or not. While this can prevent unexpected failures, but it often leads to those unnecessary downtime and added cost with it. Then comes the reactive maintenance, which only starts after a machine breaks down. While this approach may seem like the most straightforward solution, but it often results in very costly disruptions and unplanned downtime. Here is where machine learning, along with predictive maintenance, steps in as a smarter, sort of a more efficient solution than we have right now. So instead of relying on a fixed schedules or waiting for a failure to occur, it uses the data that has been continuously monitored on the machine, predicts exactly when they will need the maintenance before a problem could become a bigger problem. So how it works is that predictive maintenance relies on IoT sensors, which is embedded in the machinery to collect the critical parameters like it could be temperature, vibration, pressure, etc. And this data is then analyzed by machine learning algorithms to assess the health of each machine. The system can accurately predict when a piece of equipment is likely to fail or requires an attention, allowing us to allowing us or the operators teams to schedule the maintenance at the most efficient time and hence minimizing the disruptions in the production line. Most industrial machine, as we know that, don't just stop working out of nowhere. They show early signs of wear, small fluctuations in temperatures, unusual vibrations, or other signs are often missed during these routine checks. But predictive maintenance picks up these early warning signals, giving us the lead time to act before a problem escalates. We can think of it like a machine having a communication channel for us to tell us what it is facing and where the help it needs. For example, to give on this, we recently worked with a client who manages conveyor systems moving truck cabins through their assembly line. So we installed vibration and temperature sensors to monitor the motors and rollers. And over the time, the system began identifying subtle changes of wear and signs that would have gone unnoticed with the traditional maintenance that they were doing. When these early warning signals gets detected, the system generates alerts to the team to schedule the maintenance before there are any serious signs of breakdown that could occur. So this approach helps us to prevent unnecessary downtime, cost related to that, and also increase the lifespan of the equipment and ultimately boost the client's overall production efficiency. Now let's say the market growth of predictive maintenance as well. In 2024, it was valued at approximately 10.93 billion and is expected to reach 70 billion by 2032. So this growth reflects the increasing integration of predictive maintenance in industrial operations worldwide. So technologies like IoT, condition-based monitoring, and advanced analytics are supporting this shift that is happening. Industries like manufacturing, energy, and transportation are leading adopters of this. As digital transformation deepens even more, predictive maintenance is going to become an integral part of asset management strategies in the plants. Now that we understand predictive maintenance, what value it gives us, let's explore how it supports us. So, firstly, as I mentioned before, it continuously monitors key machine parameters. It could be vibration, temperature, using specialized sensors. This real-time monitoring allows machines to communicate their condition, helping us to detect issues early on. Operators receive timely alerts about potential failures, helping the maintenance team to plan ahead and respond proactively in terms of maintenance. Maintenance schedules are optimized, reducing unnecessary inspections and focusing on the efforts where they are truly needed. By tracking the remaining useful life of those components, it helps us to extend the equipment lifespan and avoid any premature replacements. And ultimately, it reduces the unplanned downtime, ensuring a smoother production and an improved overall operational efficiency. Now, how predictive maintenance can be implemented in the plant? So the implementation process starts by identifying the critical assets that will benefit the most from a predictive maintenance program. Once these key machines are selected, appropriate sensors are installed at a strategic location, like it could be motor bearings or any other important components of the machines. Following the sensor installation, data collection begins, and this data is sent to a centralized system for the analysis. Again, we apply machine learning algorithms to assess those vibration patterns and other signals to detect if there are any anomalies and predict the machine's condition over coming days or months. The predictive maintenance system often integrates with the existing asset management platforms like ERP or CMMS to streamline those maintenance workflow so it becomes easier for the operators to have this routine in place. And throughout the process, data security and management also remain a top priority when implementing such application. Again, based on the predictions, maintenance teams receive timely alerts and messages about the potential issues, helping to gain the proactiveness of scheduling the maintenance that minimizes the disruptions and ensures continuous production flow is maintained on a daily basis. Now, let's see some of the key benefits of predictive maintenance. Firstly, as we know, reduce the downtime. By anticipating potential issues, we can reduce the downtime, especially the unplanned one. Data driven maintenance activities are guided by real time data coming from the machines rather than fixed schedules. Cost efficiency with fewer unplanned repairs and optimized maintenance timings. Overall, operational costs are reduced, enhancing the cost effectiveness tied with those machines. Now, when it comes to cost of implementing such applications in the plant, the usual cost of predictive maintenance averages around 88,000 per month. And this comprehensive fee includes sensor installation, system operation and monitoring, and also staff training that we saw in our previous application. And also SLA, where a 24 bar 7 support is always provided. So while this initial investment might appear significant, it is very important to consider the broader impact we can get from it. That is unplanned downtime and emergency repairs, which often result in a substantial direct or indirect cost. With predictive maintenance, we can help to avoid it. Even a single preventive breakdown can justify the monthly investment several times over, making it a valuable and a strategic investment for the organization. Now let's look at another application called sales forecasting using machine learning. So while this is not directly part of manufacturing operations, but plays a very important role in managing sales and inventory effectively. So for manufacturers and retailers, producing and stocking the right quantity at the right time is critical. And especially for those who deals with perishable goods where overstocking can lead to waste and understocking to missed sales opportunities. And many organizations, in fact, still face and struggle to create accurate sales forecasts due to limited or a fragmented data with rigid forecasting models and a lack of business context in the data residing in the business. And to address such challenges, businesses need a forecasting approach that uses a comprehensive data and which is also flexible enough to adapt to their specific needs. Machine learning provides this advantage. It helps us to gain more data, which is fragmented, unifies it, and make predictions over those unified data and predictions of future sales and performance. So in addition to that, we also have a user-friendly dashboard that brings together historical sales data so we see how we did in the past and also future forecast in one place. So this transparency helps us to respond quickly to the market changes and refine their sales strategies and stay competitive in the market. Now, what is the market outlook for ML based sales forecasting? So, the global market for machine learning based sales forecasting is expected to grow from 4 billion in 2025 to 10 billion in 2032, representing a compound annual growth rate at CAGR of 11.3%. So this growth is fueled by increasing digital transformation initiatives that is happening right now and the widespread of adoptions of AI driven tools across these industries. So North America currently holds the largest market share due to early adoption of such advanced technologies, while Asia Pacific is expected to be the fastest growing region driven by rapid industrialization and increasing investments in AI solutions. Now, how do we apply machine learning to sales forecasting and how it helps us? So, firstly, it enhances the sales predictions. Machine learning combines historical data with external factors that might affect the sales, like market trends or seasonality, to provide a more accurate forecast of the future sales. It delivers up to date information that helps the companies to quickly adjust the production plans and respond to that fluctuating demand that they see. By improving demand prediction, it helps us to maintain that balanced inventory levels, reducing both overstocking and stockouts. Then we have data driven information that supports more effective pricing strategies and targeted market efforts to maximize the profitability and the competitiveness of the business in the market. Then forecast powered by machine learning helps the business to create realistic budgets based on the information that is backed by the data. Early detection of any potential risk allows for a quicker or a more informed decision making, minimizing those disruptions or the losses of the revenue. Now, these are some of the value that we can get from sales forecasting using machine learning. Let's see how these can be implemented into our existing workflow. First, we gather historical sales data, usually covering the last 3 to 5 years, to understand the past performance. Next, we decide the forecast period, whether it's weeks or months or the quarters ahead we want to see. Then we bring in external data like economic indicators, it could be consumer confidence as well, and also the industry trends to add important context to the sales. We also conduct market research to get a clear picture of the current market dynamics that the business is in right now, and also the customer preferences of the business's products. And after that, sales are broken down into product categories, customer segments, region wise, and we sort of have a distribution channels because each group behaves differently and needs a tailored analysis, as we know. And with this prepared data, we select the right machine learning algorithms to spot those patterns, again analyze the trend and create a more accurate forecast. So over time, as more data flows into these systems, the model learns, the forecast gets sharper and more reliable, helping the business to make smarter decisions ahead. Now let's see what are the key benefits that we get from it and also the cost associated with it. Firstly, accurately predict demand to avoid any overproduction and reduce the cost. Maintain that ideal inventory levels, preventing both overstocking and shortages. Incorporating trends and patterns for more reliable forecasts, supporting a smarter decision, better decision making in the organization. Now, regarding the cost, machine learning based sales forecasting services priced at 1,95,000 per month, covering everything from data integration and model development to ongoing monitoring and maintenance and support as well. So we handle the entire process, so you don't have to worry about the technical details that goes behind such applications. While it may seem a very significant investment, but it is designed to help you avoid any issues that is related to overproduction, excess inventory, and also the stockouts. So by having an accurate forecast compared to the traditional forecast that we do right now, we help optimize the inventory, reduce waste associated with that, and also overall improve cash flow, saving some in the long run. Plus, the service is again flexible and can be customized to fit the specific needs and the budget of the business. Now, for our final service today, let's see about digital twin, which is a powerful tool that is changing how manufacturing operations are managed and also optimized. So, what is digital twin? It's a virtual companion for our operations of the machines and the process. So it continuously monitors the performance of process and machines like we saw in predictive maintenance and visual inspection, and alerts us if there are any potential issues and suggests improvements in real time. So a digital twin sort of creates a live digital replica of physical assets that is there in the productions. It could be systems or the processing, and the connection and forms a connection between physical and digital worlds, which helps us to take a faster and smarter decision when it comes to product development and having operational excellence. For example, as you can see in this dashboard tracks energy consumption across various parts of a facility in real time, from HVAC systems to lighting and machinery. So digital twin helps us to monitor such critical parameters of the process and the machine and adjust that energy usage in dynamic. So identify inefficiency and guide data-driven improvements are the second nature for this implementation. It also supports sustainability efforts by reducing waste and also lowers the carbon footprint that we want to have. Now, everything that we have covered so far, from visual inspection to predictive maintenance, is built on the foundation of the digital twin. As we know, it integrates real time data from physical assets and turns it to an information, allows us to see where we can predict and respond confidently in the manufacturing environment. In other words, we can say that visual inspection and predictive maintenance are specialized applications within the digital twin ecosystems, demonstrating how data driven information are really transforming such industrial operations in the manufacturing facility. Now, what makes digital twin so valuable? So digital twin firstly lets us to simulate scenarios without any real world risk, helping to spot issues in the early development of any product and save some time for us. By pinpointing bottlenecks and if there are an inefficiency, we can streamline the process and see where we can boost that productivity. By using predictive insights, we catch problems before they happen, reducing the downtime that we saw in predictive maintenance. Testing and refining the products rigorously virtually speeds up the development and lower the cost that we have to bear in the real world. Real time monitoring means we're always in tune with how the assets perform and can make quick adjustments then and there to get an optimization out of the process or the machine. By optimizing energy usage and minimizing the waste, it can help us to build a more sustainable future that we are all looking for. Now let's see what are the benefits of digital twin. Firstly, by automating tasks and cutting down those inefficiency, it helps us to get more done with less effort and with the existing resources we have. Real-time data keeps us informed and we can fine-tune the machines and the processes on the go. Early detection of issues means fewer breakdowns and less spent on the repairs. Now, when it comes to cost that is related to digital twin, it starts about 2,73,000 per month, depending on how many components we connect and the project scope. This fee usually includes everything from setup and implementation, daily operation and management of such application, and quick response through our service level agreement, and of course, staff training and ongoing support. And if needed, we can choose the implement specific modules individually. They'll work on their own without requiring the full digital twin setup. And that concludes my part. I hope this provided a good understanding of these technology and how they can support us. So thank you everyone for being with us today. And I'll now hand over mic to Pravina. Thank you.
Thank you so much, Vaishnavi, for the enlightening walkthrough on AI/ML technologies and how they are set to transform the manufacturing ecosystem. It's truly a game changer, isn't it? The cost efficiency you highlighted, show just how the accessible these innovations are, even for the factory of any sizes. So fantastic insights. Thank you once again. Now, thank you. Now, all you might have wondering, how do we actually bring these technologies into our own factory setup? Is it complex? Will it disrupt any existing process, right? The answer is refreshing simple. So with a small strategic step, manufacturing 4.0 can be a successful integration into your operation no matter where you start from. At Opsio, we place a unique challenges and a goal at center of every transformation journey. So, as this slide will represent, a purpose-driven implementation of AI, ML, and IoT doesn't have to be very difficult or expensive or risky. And here, how we make it happen with easy steps. So you don't need to replace existing machineries or worry about the age of your equipment. With a small IoT add-on and sensor integrations, we can capture the critical operations from your current setup seamlessly and cost efficiently. Start with one machine or one line or one process. This limit the risk and reduce the upfront investment, right? And focus on areas where you can gain a quicker visible wins to build a momentum. Once you begin to see a measurable impact, the same strategies can be scaled across more machineries or a production lines systematically and efficiently. For any new equipment purchase, considering the partnering with our innovation providers like Opsio, it helps us to build a single vendor model for a streamline to do the oversight, consistency, and perform optimizations within your ecosystems. By following these practice steps, manufacturing 4.0 become not just achievable but scalable and sustainable by nature. This approach helps you to secure a quick wins while laying the groundwork for a long-term success plan. Now that we have seen how the implementation can be simple and scalable, let's move on and explore some of the exclusive offer we put together to help you to get started right away. We are excited to offer you a free assessment discussions through our current proof of concept engagement. You have already know your business's challenges and opportunities better than anyone, and we bring a deep expertise in the latest technologies and their practice implementation. Let's connect for the no cost, no obligation initial assessment. This is the sessions we will bring with you or we will work with you completely to understand your specific need, suggest a tailor-made solution, and provide a clear estimate. If the purpose works well with you, we will proceed to the implementation of solutions at your site and demonstrated the real measurable result. Once you are satisfied, you can move forward with the full scale of deployment or commissioning at your sites. Let's take a small step first towards the big transformation. So you can reach out to me directly on this discussion via email or a phone. Meanwhile, we are sharing a quick feedback form in the chat right now. It's will take only a minute to complete. Once you have submit, we will get in touch with you to schedule a meeting around the application you are most interested in. Therefore, as we have now reached to the final slide of our presentation, I would like to take this moment to sincerely thank you, each and every one of you, for joining us today. Your time and engagements means a lot, and we hope this session has sparked a new ideas and encouraged you to take the next step towards the innovation and growth. Remember, every big challenge or a change start with a small step. If today's conversation has inspired any thought or question, please do not hesitate to reach out. We would be more happy to continue the discussion beyond the session. Also, be sure to make your calendar on our upcoming webinars. On 16th July, we have upcoming few of the webinars going to be live. Let's keep the building the momentum together and we work towards the smart and more efficient future. My heartfelt thanks to Vaishnavi for her outstanding presentations. Her insights brought immense value to the sessions. So once again, thank you for being here. We wish you a fantastic day ahead. Make sure, please follow Opsio India page on LinkedIn for latest update, insight, and future events. So again, start small, think big. Signing off. Take care and see you next time.